Okay, page 34. Okay, can you try to do by yourself a little bit? Okay, Joanna, I'm buying you time to clean up your table. Hurry up.
Do the 34 page 34.
Yep.
Oh. 34. Yes. Okay. Teacher, is it the wool hat is can you talk inside it and others can't hear?
Say again, I don't get what you mean.
是不是那个你讲话在那个 wool hat
什么是 wool hat？应该考我明白什么是 wool
wool hat
hat？帽子。哦，it's harder. It's harder. It's
Oh,
harder.
no have this one lah.
Okay. Shall we discuss this part? Okay, so let's just go through a little bit. Okay, later we'll do a little bit about sound. Okay, how sound transfer is vibration. Okay, so yesterday we learned about the source of sound, where the sound come from. Okay, so the sound will transform into vibration that goes into our ear. So later I'll need you to fill in all this, to say everything about how the transfer to your ear, as well as all the functions of the ear. Okay, so when sound transfer through vibration, okay, this is where it comes from. Some materials is easier to transfer the sound, some is harder. All right, so we want to do this experiment over here to identify which is the method that which is the material that the sound transfer the best, and which are the material that the sound transfer the poorest. So let's see over here. Liu and Ming listen to sounds through different materials. They listen through air, water, and so on and so forth. Okay. This is the bar chart that they drew to show how loud the sounds were. Use the bar chart to answer the question. So you see, when they hear through air, it's like, oh, they can hear like a little bit of sound. But when they hear through hard, solid stuff, okay, you will notice here. Okay, you notice here, solid stuff, it's easier to transfer vibration. Okay, because it vibrates, it's like, hey, very fast, I can hear the sound already, because solid, right? So when it's very close together, it's like vibrate a little bit, I can hear already. But water, it's liquid. Liquid, I can hear better than air, all right? But however, air is because it's a gas, that's why it's transfer the sound the poorest, Okay, that is why it's like when I use a wire, okay, I can hear better than I just talk like that. Okay, so this is the reason. Okay, is the material through which the sound was loudest a solid, liquid, or gas? Loudest, which one? Jensen.
Solid.
Fantastic, solid. Number 1A, solid. Liu and Ming also listened to the sound through a wool hat. The loudness of the sound, yep.
Wool is the sheep.
Black sheep, have you any wool? Okay, understand what's wool? Okay, wool hat. The loudness of the sound is 3 decibel. Draw another bar to show this. So, draw the bar. 3 is over here. Draw it like this. So just now it's not that Wu cannot hear like what you asked, is that they haven't drawn. Trick you, Joanna. So is wool a solid, liquid, or gas? Wool is a solid. But why? Steel can hear better than wool. Because steel, it is very hard, so you can transfer very clear. But wool is like here a bit, here a bit, here a bit. So that in between gap, there is air. So that's why the transfer is not as good as steel or wood. Understand? Because in between it has the air gap, which is gas. Understand? Okay. Next, Jensen. Which kind of material does sound travel best in the chart?
Steel.
Very good. Understand? Okay. If no problem, I'll need you to do this now. Okay. Hold on, before that, I'm sure something with you. Okay. So this is pretty much all about sound. How do they transfer through solid, liquid, and gas, and which is the best medium of transfer? Let me share the sound.
Adapted Mind Math! Come explore the site with me. I'm in first grade, so I'll pick that.
Bubbles, can you bring me my bag? Where is my bag? Why did you not bring my bag, Bubbles?
I couldn't hear you, Spiky.
But I called you so many times.
Oh, maybe because your sound did not travel to Bubbles.
What? Does sound travel?
Yes, sound travels. But how can sound travel? Sound is a form of energy that spreads from its source in all directions. We hear sound when vibrating particles hit our eardrum. Sound moves when the particles hit each other and pass on the vibrations. That's why sound needs a medium for its propagation. The medium may be a gas, such as air, a liquid, such as water, or a solid, such as metal. Do you recall the last time you saw lightning? You saw the flash of lightning first and heard thunder only a few seconds later.
But why did you see lightning first?
So who can tell me why we see lightning first and only thunder?
Because the sound travels.
Because the speed of light is faster than the speed of sound. Okay, so that's why we see first, then we hear. Okay, it's actually happening at the same time. But sound travels slower because it's through the air.
Sound travels more slowly than light in air. So sound takes longer to reach us. The speed of light is almost 1,000,000 times faster. Air is made up of gases. The particles in gases are farther apart than in liquids or solids. It takes longer for one gas particle to hit another gas particle and move the sound energy along. Sound can travel through other mediums than air. In fact, in water, sound travels faster and can travel further. Particles in water are closer together. That's why sound travels more quickly in water than in air. Sound waves travel even better through solid things like wood or metal. The particles in a solid are tightly packed, and sound waves travel fastest in this medium. Let's find out how sound travels in solids. Tap your desk with your hand and listen to the sound it makes. Now put your ear on your desk and tap the desk again. Did you notice a change in sound? Which one was louder?
The one that I heard by putting my ear on the desk.
The sound is louder because the sound vibrations travel faster through solids than in air. When you heard the tap the first time, sound waves traveled through air. But when you put your ear on the desk and heard the tap, the sound waves travel through the desk, which is a solid. In outer space, you can't hear anything because there is no air or any other matter. We call this a vacuum. So there is no medium that sound can use to travel.
Okay, can you please write down in the chat? Okay, sound can't travel in vacuum. Okay, sorry, I typo. Okay, sound can't travel through vacuum. Okay, because there's no medium, there's no way the sound can travel. Understand? The sound must travel through a medium. So gas is like air is also a medium, all right, which is a plural. But if it's vacuum, nothing. Vacuum is nothing. There's no way you can. Okay, so what other vacuum things are like, for example, sometimes the bubble wraps, I don't know. Sometimes they have bubble wrap, right? Like for example, you buy chips, inside it's a vacuum. You hear it's like you can't hear anything inside. Okay, because it is vacuum. Same thing like the thermal flask also actually have a vacuum gap. All right, so that's pretty much sound can travel through any medium. Best medium is solid. Poorest medium is gas, but it can't travel in vacuum because there is no medium in vacuum. Okay? Okay. If no problem, okay, can you try to do this? Fill in the blanks and then after that share it. This is pretty much what we learned yesterday. I go and get some water. So once you're done, can you just drop me a message in the chat? I'll just leave for a minute. Is it all done? Can we discuss? Yeah, all right.
Let's go have
Okay, how about we discuss? Okay, so basically, let's see my screen. Okay, there's 3 sections of the ear. The first is actually outer, sorry,
I
outer,
know the
outer, middle, and inner. So this would be easy part. Okay, this is actually called pinna. Then the drum, dong 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 drum. Before that, it goes through a canal. Okay, and then after that, basically this circle is called cochlea, which is transfer from, okay, this is the amplifying sound, which is called the ossicles. Then after that, go through the semicellular canals. Then cochlea is where the water liquid thing, and it's going to the transfers from the vibration into electric waves going to our brain. Understand?
Done.
Done? Understand now? Okay. If this is done, now a little bit harder. Same thing. Okay, same thing. Okay. The labeling, I think you can just skip it. No need to do the labeling, but I just need you to focus on this. Write the correct words. Okay, so like for example, okay. All right. For example, the sound vibration travel through the air. Okay. It's called sound wave traveling. Okay. Fill in here. The sound waves are funneled into the ear by this, the tunnel. What is it called? Okay. So please fill in this blank space on this. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. Fill in all over here. Then share the screen with me and we'll discuss. Okay, I just want to focus on number 2. Number 1, we can skip first.
Teacher, sorry.
Yep.
Like this.
Did I not send to you yet?
Yes.
Oh, sorry. Okay. Shall we discuss?
I don't know how Hmm.
Okay, let's discuss that. All right. I can't make it smaller. Okay, let's just do the top portion first. Okay, what I suggest is that every time when this question, try to highlight the words like funnel, vibration, vibrate, small bone pass to cochlea. All right, let's try to do one by one. Okay, so now first of all, it's that vibration travel through air. So, which means that sound wave traveling. Okay. The sound wave are funneled into the ear by this. Okay, how does the sound funnel? Okay, look at my video. Okay, the sound wave go in through your ear through the through our this what you call pinna. The pinna, which is actually called the outer ear. Then the sound wave travel along this inside over here. So let's see. Okay, first it start from the outer ear, which is the vibration. Okay, then go through the outer ear, the sound vibration. This is the sound vibration. Then go through the outer ear here, and then after that travel along this long tunnel, which is called the ear canal. Ear canal. Okay. Then once it goes into the ear canal, it's like it will start to vibrate. Vibrate, remember, dong 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 dong. So this is the ear drum. Okay. D is eardrum. Okay, next. After it goes through the eardrum, pass by these small bones. Okay, the small bones is basically the ear bone. Okay, here they say it's ear bone. Okay, in simple words, it's also ossicles. Okay, ear bones. Okay, the spiral tube contains liquid. Remember what I told you about liquid? Liquid is inside the cochlea over here. This thing cochlea, that's where the liquid, where remember I told you if you swim too much or stuff like that, you will like feel off balance. Cochlea. And then it sends the electric signal to the brain. So this is the one that goes to the brain, which is auditory nerve. Okay. Understand so far? Any question here so far? This is exactly same like the homework I gave you yesterday. Right? Let me copy what I gave you yesterday. See, this is where it funnels into the ear canal. So ear canal is a tube that goes to the eardrum. This is the one I said make vibration louder. Okay, then this is the auditory ossicle, which is also you can call it as the small bone. It's to amplify the sound. Then the cochlea, which is to have liquid there. Okay, that change the vibration into electric signal. Then auditory nerve is the nerve that goes into our brain. Okay, so that's why sometimes if we break our backbone, this nerve is broken. Our ear had no problem, but we cannot hear. Okay, because this broken, so it cannot go to our brain. Even our ear is perfectly fine. Understand? Okay. Same thing on top. Instead of in point form, we are rewriting in paragraph. Can you try to fill in the blanks? Okay. Shall we discuss together? Okay. Something vibrates to produce a sound. Sound travels through medium or air. Okay, so here don't have medium, so it's air to the ear. When the vibration reach our eardrum, it transfers to small bones called the hammer. Okay, which is the 3 ossicles. The bones pass a vibration to the cochlea. This contains sense cells which change vibration to electrical signal called impulse. The auditory nerve takes to the brain. We hear the sound when the message reaches the brain. If no particles to produce, if no vibration, we will not hear the sound. Understand? Okay, so this is pretty much what we have learned earlier, so you know how to do this by yourself, right? Okay. All right, so this is exactly the same thing I taught you just now. Exactly. Okay. So can you try to do this by yourself? Okay. All right, so that's pretty much all for today's homework. So everything about ear, sound, vibration. All right.